A sequence is just a list of numbers. So if we have 1, 2, 3, 4, 5, this is a sequence. It's a list of numbers. Now, this particular list of numbers is known as the natural numbers that we use for counting. Natural number, or we can also call this list of positive integers. So, a sequence is a list of numbers. Now, we can look at a particular list of numbers and we can have names or labels for them. For example, if I write a list of numbers, uh, U sub 1, U sub 2, U sub 3, U sub 4, U sub 5, and on, and we can use these things for labels. So U sub 1 is the label of a number that was supposed to be here. So here 1 is U sub 1, 2 is U sub 2. We call this particular number in a sequence the term. So let me formally write it down. So sequence is a list of numbers, is a list of numbers. Each number is called a term. So each number in the sequence is called a term. That means this is a term, this is the second term, this is the third term, and on. So this U sub 1, U sub 2, U sub 3, these are labels where we are supposed to have numbers in that. Now we have some more sequences that we can use. For example, the odd integers or the even integers. If we use 2, 4, 6, 8, 10, 12, and on. So this is even. So we have even integers. It's a sequence. So even integers. Now we can actually figure out by looking at it that it is increasing by 2. And from this that goes on forever, we can figure out the next particular term would be 14, and the term after that would be 2 more, that would be 16. We also have 1, 3, 5, 7, 9, 11, and on. This is sequence of odd integers. So we can actually figure out the next term would be 13 and the term after that would be 15 by looking at the logic of the sequence. The sequence is increasing by 2. Every value, every number of any sequence is known as a term. So U sub 1 or first term is 2, U sub 2 or the second term is 4, U sub 3 or the third term is 6. That's how it works. The most famous sequence in the world is probably the Fibonacci sequence. Fibonacci sequence. See whether you can figure it out. So 0, 1, 1, 2, 3, 5, 8, 13, it goes on and on. Now what could be the logic behind this? If you see, this is not obvious when you look at it for the first time. If you add the previous two terms, so 0 plus 1, you get the next term 1. Again, if you add these two terms, you get the next term 2. Again, if you add these two terms, you get the next term 3. Again, if you add these two terms, you get the next term 5. If you add these two terms, you get the next term 8. And if you add 5 plus 8, you get 13. So if you want to find the next term, it would be 8 plus 13. So the Fibonacci sequence is a very famous sequence list of numbers, but it might not be obvious to someone just looking at a sequence. Another term that is important is infinite sequence. If a sequence keeps on moving, that does not end, there would be some other terms. We call them infinite sequence. And we give 3 dots like that. That means there are other terms after that, meaning more numbers after that. So let's take a look of some sequence and see whether we can, just looking at it, figure out the logic and what the next term would be. So we have four sequences over here, and we have to figure out what the next term would be. Let's take the first example. This is 2000, this is 1000, this is 500. So this should be 250, half of that. This should be 125, half of that. But here, the second term is negative. The third term is positive. Then this term should be negative again. So this is the logic of the sequence. The next one we have 25, then 36, then 49, then 64. So it looks like we have squares. This is 5 squared, this is 6 squared, this is 7 squared, this is 8 squared. So next one should be 9 squared, which is 81. The next one should be 10 squared, which is 100. Now you see again the even positions are negative. So second one is negative, fourth one is negative. So this should be minus 100. The sixth one should so this should also be negative. Now here we have 330, 170, 90, 50, 30. It is decreasing. Let's see by how much is it decreasing. So this is 40. It is decreasing by, this is decreasing by 20. Now this is decreasing by 40. Now this is decreasing by 80. Now this is decreasing by 160. So numbers are decreasing, and they're decreasing by half. So 160, half of that is 80, half of that is 40, half of that is 10. So this should be 30 minus 10 is 20, and this should be half of that, which is 5. So this should be 15. This is not that obvious. You have to actually check how it is changing. The next one we have 81, 27, 3, 9, 3. So this is 3 to the power 4. This is 3 to the power 3, 27. This is 3 to the power 2, 9. 3 to the power 1 is 3. This should be 3 to the power 0, which is 1. And if you want a next one, it should be 3 to the power minus 1, which is 1 by 3. So that is the logic of this particular sequence. Now it is also possible that you would be given a logic of a sequence. For example, you don't know what u1, u sub 1 is, you don't know what u sub 2 is, you don't know what u sub 3 is. It goes on like that, but you know the logic by which a particular sequence progresses. Suppose this particular sequence is a particular term is 2n plus 1. And if they tell you find the first term, all you have to do, put n equals to 1 over here, plug it in. That would be u1 equals to 2 times 1, 2 plus 1, 3. So the first term would be 3. And then if you put n equals to 2, then you'll get the second term, u sub 2, which is 2 to the 4 plus 1. This is going to be 5. So the second term would be 5. And the third term would be n equals to 3. It would be u3. That would be 2 into 3, 6 plus 1, 7. So this is 7. So now that you have the expression or some sort of a function by which you can know the next term of the sequence, you can actually write down the terms of that sequence. That is also possible. Now, before ending, I would like to mention about series. Series is the sum of the terms of a sequence. In other words, it's the sum of a sequence. So if a sequence is u sub 1, u sub 2, u sub 3 and on, list of numbers, if you add up the sequence u sub 1 plus u sub 2 plus u sub 3 plus and on, it goes on. So we call this a series. And the logic of a sequence and the logic of a series is exactly the same, because a series is just a sequence added together.